So hi everybody, I'm PhD candidate Nicola Capodieci, and I'm here to present my research report on the first year activity of my PhD. My supervisor is Professor Giacomo Cabri. So the title is Self-Expression in Ensembles of Autonomic Components, specifically to case studies of distributed robotics and smart grid scenarios. So according to IBM's vision of designing autonomic components, the current trend in designing and developing ensembles or sets of computational units is to think of them able to deploy the so-called self-start properties. What are the self-start properties? Here we have a small list. So we are dealing with self-repair, self-healing. So basically we want the ensemble to try to autonomously recover from fault situations, but also self-stabilize. So step back from illegal state configurations to legal state configurations. So also faulty situations, but in a more softer way point of view, more code instead of hardware. Also, the ensemble has to be able to self-organize, so to decide plans to take in order to achieve certain goals with specific utilities. The goal is to have self-adaptive components, so components able to promptly react to external and dynamic variation of the surrounding environment that we suppose to be open and not deterministic. So from all the above mentioned properties, we are thinking about adding another one that we call self-expression, which we define as the ability of an ensemble of autonomic components to deploy changes in coordination pattern during runtime execution of tasks of variable complexities. So why are we doing this? Just think about all those systems which, in order to function, they need to rely on continuous human inputs, or systems that they are not able to be stopped, and then a human user could tune the system, basically. So systems that cannot be stopped and systems that without the autonomic features would require human inputs. And all of this is part of European project with several case studies. Some of them are listed here, but mainly in my research I'm focusing on multi-agent system in the smart grid and distributed autonomous robotic systems. So, for example, regarding multi-agent system in the smart grid, the scenario is the deregulated energy market, so a newly liberalized market in which the consumer of electric energy will be able to contract for electric energy also with this night boring prosumer, so a small-scale producer of electric energy with renewable energy sources like solar panels and wind turbines that can be now installed also in domestic environments. So, if we are talking about the negotiation part between those different kind of agents, we can think about this prosumer being able to decide whenever it is convenient to them to aggregate into a virtual power plant, so centrally, so locally centralize the negotiation, or act as lone operator, and so shaping a more peer-to-peer coordinated approach for handling negotiations. All of this is decided with very variable for example, the weather and raw material prices that are constantly oscillating over times. So this is what we mean with dynamic of the market. Changing subject on our case studies, as swarm robotics, we can think about ensemble of robots that they have to coordinate in order to solve specific tasks. In particular, a task of exploration can be solved using several coordination patterns. We can think about bio-inspired approach in which every robot is unaware of the presence of another robot, and they are basically have to distribute sub-areas to explore. And they can do that by placing digital pheromones, or in the other case, they have some sort of round-table discussion in which they, using protocols, a peer-to-peer system in order to negotiate areas to explore. And we can see how, in terms of utilities, those coordination patterns can allow the ensembles to reach the goal, but obtaining different utilities. In particular, a swarm-driven approach, so the bio-inspired approach, is better in terms of TTC, time to completing the task, because they don't have the overhead of coordinating in a peer-to-peer approach. But on the other hand, if we use purely bio-inspired approach, they have no way to distribute equally the load of work. So the point is, the main challenge is now how to define self-expression, and more specific, even the concept of coordination pattern. How can we formalize this concept in order to create some sort of methodology to apply in all those cases of studies? We are trying several approaches. We are trying to extend the notion of dynamic role assignment in multi-agent system. Instead of assigning roles to specific agents in our system, we are specifying coordination patterns, or role that will specify coordination patterns. Another important point is how we describe this coordination pattern. We can use UML diagrams. We can use finite state machine of Markov chains. The point is to underline commonalities between code and state, and so we can figure out a way to exchange just the minimum amount of code or migrate the minimum amount of agents or processes in order to have this change in a coordination pattern. Another approach that we are going to investigate is also a bio-inspired approach. It's called artificial immune system, that takes inspiration from the human immune system, which is a very nice example of multi-coordinated, highly scalable, and functioning distributed system that uses a lot of concepts that we can use in our problem of coordinating ensembles of autonomic components. That would be it. These are a list of some related publications, mainly related with case studies. Thank you very much for your kind attention and questions.
Okay, thanks again. The next candidate is Mr. Fabio Sosci. So we change area a little bit.
Okay.